All right, so compound interest, this is where I get pretty passionate about you understanding real world and math. Okay, so I'm going to give you my real life example as we talk about this because it's incredibly important for you to understand this as you guys get ready to transition into the real world. I mean, not like you're not already there, but if you're going to college or if you are ever going to get a loan for a car or for a house or whatever. Okay, because that's the nature of America. It is the land of the free, but it's also the land of the bondage of money. So anyway, here we go. Okay, so let's look at this formula. So you have heard probably before at some point about things earning interest, whether it's credit cards that earn interest or whether it's a savings account that earns interest. So we're going to talk about how interest is accumulated onto that amount of money. So this formula that we have, A equals P times 1 plus R over N raised to the NT, it looks very familiar to the other one from yesterday. You guys remember the one we did yesterday? That VN thing? Okay, it's the same, basically the same thing. The only thing that's really different is that every time we are adding, so there's no option to subtract when you're doing interest, and then we have to take our rate and divide it by N. N is the new thing where it is the investment period. So how many times a year is this happening? All right, so I wrote down kind of a cheat sheet here for you. If it says semi-annually, that means that it's happening twice a year. Quarterly means it's happening 4 times a year. Monthly means it's happening, obviously, 12 times a year. Okay, so that's kind of the thing that we have to pay attention to that's new here. So number 4, example 4 says, suppose when you were born, your grandparents put $5,000 in a savings account that earned 6% interest compounded quarterly for your college fund. At age 18, how much money would be in your college fund? So what might be our first step here? Say that again, Patrick. Write down the formula. Okay, so we're going to write down our formula. A is the amount that we want at the very end. What is my starting value? What's going to be the P value here? 5,000. Good, 5,000. So I'm going to label that as my P. What is the rate here? 6%, but when I go to plug it in, what do I have to do? You have to divide it by 100. Good. So we get 0.06 is going to be my rate. Then it says compounded quarterly. And if we think about quarterly up there, if you look at the notes where I said if it compounds quarterly, how many times a year is that? 4 times a year. So N is 4. And then T is how many years have passed. How many? 18, right? Because at age 18, if when you're born from age 18, that means that 18 years have passed. Okay, so let's go ahead and plug in what we know into our formula. That 1 is always there. Okay, so we have it set up, 5,000 times 1 plus 0.06 divided by 4 raised to the 4 times 18. So before I really start plugging this into my calculator, let's simplify some things. What is 0.06 divided by 4 in your calculator? What? It should not... 0.015 right here. Check that again, Anthony. 0.06 divided by 4. Okay. So if we add that to 1, then we're going to have 5,000 times 1.015. Would you guys agree with that? And then raised to the 4 times 18. So what is 4 times 18? 72. Now is the point that I can use my calculator. What do we want to do first here, Crystal? Am I going to multiply 5,000 times 1.015, or am I going to take 1.015 and raise it to the 72nd power?
Yeah.
Yeah is an answer?
1.015
Perfect. Okay, so Crystal's reminding us we need to do this part first. Again, let your calculator hold that number. You don't need to write that number down. So 1.015 raised to the 72nd power, push enter. Everyone know how to do that on the calculator? The raised to, that's above the divide sign, that little caret sign. Okay, so once you have that number in your calculator, you're going to multiply, so just hit times 5,000. Okay, so if I take 1.015, yeah, that did not work. 0.015 raised to the 72nd power times 5,000. I'm going to have $14,605.79 in my account, right? So we're going to write that number out. So again, we write it in a sentence. After 18 years, there will be $14,605 and what did I say? 78 or 79? 79 cents in the account. Is $14,605 enough to get a 4-year degree?
No. Well,
it does depend on where you go, but is it common to be able to get a 4-year degree for $14,000? No. Do you guys know how much? We are not talking Ivy Tech. Do you guys know how much it costs to go to a year of school at IUPUI or Ball State? How much? Try again.
Like 50,000.
No.
$58,000.
That's like AU. To go to IUPUI for 1 year, if you're not living on campus, IUPUI is about $22,000. Yep. Ball State is about $25,000 a year.
What?
Okay, AU is probably about $32,000 a year now. When my sister went there, it was like $24,000. That was in 2004. It's so high because it's private college. So there's a difference between public and private, right? So like IUPUI and Ball State and IU, those are all public colleges, and so those are not, quote, as expensive. I mean, at this point, add on another few $1,000s, right? Okay, so I just want you to understand the breakdown of what this actually is, okay? So let's talk about part B, problem B first, and then we will come back to some more experience stuff. So let's do part B. It says, your parents estimate that it will take $80,000 to send you to college for 4 years. That's if you don't fail any classes. That's if you don't live on campus. That's if you don't change your major. Okay, like if you don't do any of those things, $80,000 would barely cut it at not an Ivy Tech. All right? So we have $80,000 is what we want to end up with. So if we think about our formula, what is the $80,000 going to represent? The what? It's what we want to end up with, right? So it's actually going to be our A value. So $80,000. It says, how much should you have started with? So what are we finding in this problem, actually? That P value, right? How much should you have started with at your birth so that you can get $80,000 after 18 years? So we're solving for P. Everything else in our equation is still going to be, we're going to assume that it's the same. So we have that 1.015. It's happening quarterly for 18 years, so that's still 72 up there. This one's a little bit different. How are we going to solve this for P? Anybody know how we're going to solve this for B? P. Not divide P. Okay. Okay, so what I hear you saying is that between here, this is a multiplication problem, right? So I'm going to divide this side by 1.015. It is what you're doing, and we're just saving some steps. Because if you do 1.015 to the 72nd power first, you're going to have a really long decimal that you're going to have to divide by. So instead of doing that, we cancel out. And on the other side, I have 80,000 divided by 1.015 raised to the 72nd power. When you put this into your calculator, you need to put parentheses around the entire 1.015 to the 72nd power. So 80,000 80,000 divided by 1.015 raised to the 72nd power. And I'm getting $27,386.40. I don't know about you, but I don't have $27,000 sitting in my pocket, ready to put into a bank account. My parents didn't either. I have 3 sisters, and we all went to private college. We did not have this money laying around. Okay, so $27,386.40 should have been invested at birth. That's what we need to write. 27,000. Okay, so we don't ever start a sentence with money. Okay, so we could say the amount that should be invested, or should have been, invested is 27,000. What was it? 386,000? 386. 386, yes? And $40. 40, yeah, 40 cents. That's a lot of money. Yeah?
Yes.
Again, I don't know about you, but that's a heck of a lot of money to just have lying around. Okay, so what I'd like to do for just a second is I want to draw your attention. You don't need to write any of this down. This is time for, as Patrick likes to say, Mama Miriam, even though we're like the same age, but it's fine. To have a real life conversation. So I don't want you to write anything down. I want you to look up at the board. I want you to put your phones away. I want you to listen to what I'm getting ready to tell you. If you learn nothing else from my classroom in 8 weeks, hear me clearly in the next 5 minutes. Okay? Hear me clearly. I went to IUPUI for 2 years. All right? So I was like, oh yeah, sweet, IUPUI. It's not as expensive. I got a little bit of a scholarship, so I paid $15,000 for 2 years at IUPUI. Okay, I transferred to a private college in Tennessee. So I transferred to a private college in Tennessee. I got a $5,000 scholarship, which we would think is great. But I still paid $22,000 for 2.5 years because I changed my major when I went there. I don't know about you. This is a lot of money, though. This is a lot of money. My parents are not rich. But they both had stable jobs, and so I didn't qualify for very much financial aid. A lot of you in this room will qualify for what's called a Pell Grant. Has anyone heard of that?
Yes.
A Pell Grant is free money for you based on income. So when you file your FAFSA thing with Mr. Mark, most of you are going to be eligible for a Pell Grant because of your income base and your family, or if no one claims you, this is how much money. Okay, so if you qualify for a Pell Grant, please use that money. It's free. You don't have to pay it back. That's what a grant is. This money over here that I took out, these are all loans. Okay? I graduated in 2008, in December of 2008. I started paying in, because they give you a 6-month grace period. How nice of them. I started paying in June of 2009. Okay? My total debt when I got out of college, this makes me want to vomit. My total debt when I got out of college was about $70,000. And I'm not like, at this point, that number was like so large. What am I supposed to do? For every month since June of 2009, so how many years is that? we'll just say June of 2016. That's 7 years. Someone do 7 times 12 for me on your calculator. What is 7 times 12? 84. I have been paying 84. Let's add July, August, September. So now we're 87 months. I have been paying my loans for 87 months. I have not missed a month. I went back to school to get my master's. I did not miss a month. That's 87 months times my monthly payment for my student loans is $500. So someone calculate 87 times 500. That's what?
That's your rent.
Right?
3,500.
I'm sorry, say that again?
3,500.
43,500. That's how much money Miriam Henry has paid in the last 7 years. Okay, so you would think if I've paid 43,000, and guys, I'm not rich, I'm a teacher, let's be honest. Okay, I realize that I went into education not going to make a lot of money. Okay, yes, I have been blessed to be able to make my bills, but $500, like Josh said, that's a rent payment. That's 2 car payments, 3 car payments almost, right? Like, that's ridiculous that I'm paying this much. And so if we do 70,000 minus 43,500, someone tell me what that should total out to be. What did you say? $26,500 is what I should have left to pay off, right? Yeah. The reality is that I still have at least $45,000 to pay off. Wow. You know why? Because of interest. So the difference between these two amounts, I should be paying off this much, is what we think I should be paying off. But because of interest, I'm paying off $45,000 still.
Was it worth it?
I wouldn't have met all of you guys.
And your honest opinion.
Okay, so your question is it worth it? There are days when Patrick Bennett stalks me in my office that I wonder if it really... I'm just kidding, Patrick. I'm just teasing. Okay, this is what I would say to you. This $500 a month that I'm going to continue to pay till like 2024, that's another 7 years, is seriously choking me. Right? Like, $500 a month for 25 years is ridiculous. Think about how much money what could you do with $43,500? Buy a house. Go on vacation. Exactly, all this money.
It cost my biological father $43,000 to get a 35-acre plot with home already built in it in Colorado.
Okay, so I could be in Colorado right now, is what Josh is just saying.
I have a question.
Okay, yes.
Can you refinance that and get a better rate?
Sure, but I'm still going to be paying another $40,000 than what I actually took out because of interest. It doesn't matter how low your interest rate is, you're still going to pay interest back.
Right. You couldn't get it like a lower payment.
I'm at 3% interest. You can't get much lower than 3% interest. Okay? So
don't take out loans.
So don't take out loans, but here's the thing, okay? Listen to me very carefully. If I would do this again, yes, I would be an educator again, hands down. I would go to Ivy Tech for at least 2.5 years. That's what I would have done differently. Because no matter where you go to school, you have to take speech, you have to take history, you have to take social studies, you have to take all those classes, right? My first 2 years of IUPUI, that's what I did. I took the classes that everybody has to take no matter what your major is. Ivy Tech was created to be a stepping stone college. It was created for students to go there and get their general eds out of the way, their general classes, and then to transfer out as a junior. That's why Ivy Tech was created, for students to pay less money, right? Because Ivy Tech for a year is about $8,000 to $10,000. Okay, so that's a lot less than freaking $22,000 a year, right? And if you go to Ivy Tech knowing you're going to transfer out, they have a lot of cool programs. Like they have one in Ball State where you can transfer out after 1 year. You can transfer out as a junior after 1 year at Ball State. Or 1 year at Ivy Tech, straight to Ball State. They have a bunch of programs like that, okay? So my advice to you, 2 things. If you have to take out loans, if you don't have Pell Grant or 21st Century Scholar to go wherever you want to go, then you need to go, you can go wherever. But if not, my advice would be to go to Ivy Tech first. Okay, get that out of the way. And then if you want to transfer to Ball State or IU or wherever, do that. But there's nothing wrong with being at Ivy Tech for 2 years to get all that stuff out of the way. I would rather pay $15,000 instead of $30,000. Hang on to your question. Hang on to your question just a second. The second thing is this. Guys, a lot of times you'll get a loan amount. And Ivy Tech, and a lot of people don't know this, and Ivy Tech is sure not going to tell you this. Okay, so if you went on the tour, you did not hear this because they don't want you to know this. But if you get a loan from Ivy Tech for $5,000, okay, and you think, all right, well, I need to buy a computer, I need to budget maybe gas money or transportation in there or whatever, that's fine. But you really only need to use maybe $3,000 of it. But they tell you, and I'm telling you this, you get a $5,000 deposit into your bank account. A lot of us have not seen a $5,000 deposit in our bank account ever before. And it's kind of exciting when we see that amount come in, and I'm like, heck yeah! Right, let's go out to eat, let's go do this thing. But the thing is, you're going to have to pay back that whole $5,000 plus interest. So if you really only need $3,000, then tell Ivy Tech, I'm going to give you that $2,000 back. They won't say, hey, do you want to give us any of that back? They're going to be like, here's $5,000, do whatever you want. I have students that blew it off, that bought a new car, bought an Xbox, bought a new screen TV. Like, those are not necessities, and you're going to have to pay that back. Because here's what Ivy Tech doesn't tell you. Ivy Tech has an agreement with the government that if you owe them money, they will automatically deduct from your tax check before you see your tax check. And many students don't know that. But they are legally allowed to do that, to garnish your wages or your tax check if you owe them money. I don't know about you, but that's a little bit scary, right? Because you're expecting this tax check come April, and you don't get any of it, or you only get half of it because Ivy Tech took money because you owe them and didn't pay them, when you could have given them back $2,000. Okay? So be very careful when you go to Ivy Tech, especially. They're the ones that kind of sneak that in, all right? But they're not going to tell you. They're going to be like, oh, here's $5,000 loan. Just pay it back whenever. No. If you don't pay it back, and when we say you're going to pay back, we're going to garnish your wages. Okay, so be really careful about that.
You can go to Mexico. I pay for my 3-year degree like $10,000.
Okay, Paula said we can all go to Mexico where we can pay for a 3-year degree for $10,000. Road trip!
Let's go.
There's a lot of people that I know that is from USA, but they're living in Mexico because education in Mexico, I mean, in college degree is really, really cheap compared to USA.
That's a great idea.
Yeah. And they live on campus, and there's great schools and everything.
So if you have the funds to go to Mexico, there we go. And Paula will take us a tour.
Yeah, sure.
What? Yeah, are you offering Spanish classes for us, Paula, so that we can learn? She said yes. Yes. All right, letter C. How many years would it take? How many years would it take for the original $5,000 to triple? Okay, so how many years is asking us for time? If the $5,000 triples, how much are we ending up with? 15,000 is what we want to end up with, right? 5,000 times 15,000? We hope. So let's double check that. On your test, if you just guess, you're not going to get credit for it. Okay? So we have 1.015 still. That was our rate. The number of times it's still accumulating is 4 times, except we don't know how many years it's going to be. So we're going to leave t as our variable. So we're starting with $5,000. Our rate is the same. And then t is our variable. Okay, so how are we going to solve this for t? What might be the first thing I move, Anthony? The 5,000. How are you going to move the 5,000? Divide by 5,000. Good. Okay, so we're going to divide both sides by 5,000. I can take out these zeros, right? But what is 15 divided by 5?
3.
Just 3. So if 3 equals 1.015 raised to the 4t. I'd like you to look back at your notes, please, from part B, number 1B and 2B, and see what you do at this point. Take a minute to look back at your notes and see if you can figure out what we do at this point. This is 1B and 2B. Mm-hmm. Who said that? Say it again, Patrick. Put it in log form. So I have b to the y equals x, and I'm going to move it into log form. Okay, so go ahead and do that. So you should have log base 1.015 of 3 equals 4t. We're going to worry about the 4t a little bit later. What do we do with this thing right here? Good. Elena is reminding us we need to put it into change of base formula. You guys remember that from yesterday? So that we can use our base 10. Log base 10 of 3 divided by log base 10 of 1.015. This will allow us to use our calculator, right? Because our calculator is programmed to be base 10. Okay, so now let's use our calculator. Remember to use your parentheses, please.
Like
73.78. Okay, so does it make sense that it would take 73 years?
No.
No, it doesn't make sense. So we had our log base 10 of 3 over log base 10 of 1.015 equals 4t, right? And so when I get this 73.78 equals 4t, what does that mean I need to do? Oh, right, because it's happening 4 times a year. So I'm going to divide by 4 on each side. What happens when we divide by 4 on each side?
18 and a half years.
18 and a half years. Does that sound more feasible than
Yes.
72 years?
Yes.
It does, right? So then we're going to write our sentence. Go ahead and see what you can come up with for your sentence. Eight and a half or 18 and a half? 18 and a half, right? But we need to use the word, what's the important word to use? Good, approximately, right? So we said it will take approximately 18 and a half years to get $5,000 or $15,000. Okay? Questions on that? Okay, let's finish up the last type of equations we're going to have. This is called half-life of something. This is when you would do this maybe in biology class. Okay, so we have this y equals a times e to the negative kt. Remember we talked about e at the very beginning of yesterday's, or 2 days ago we talked about the e. Okay, so I tell you over to the side, a is your starting value. Notice that the starting value is always in the same spot, right? It's always the a. K is going to be the constant at which something is decaying. So it's a rate of decay. The K is going to be the rate of decay. You're still going to divide by 100 if you need to. The Y value is how much is left. The Y value is how much is left. So we talk about half-life, meaning this is like those equations that talk about a woolly mammoth lived 2 million years ago and it decays at a rate of yada yada. Find out how much is left of the woolly mammoth. Okay, these are the types of questions we're going to be asking. Okay, that's when you talk about half-life. You talk about it a lot in biology and chemistry. Okay, it says the half-life of a radioactive substance is the time it takes for half of the atoms of the substance to become disintegrated. Okay, so after something is already, quote, dead, how long does it take for half of it to be disintegrated? All life on Earth contains the radioactive element carbon-14, which decays continuously at a fixed rate. Okay, so carbon-14, that 14 is just the name of an element. Okay, it's not 14 years or 14 days, anything like that. The half-life of carbon-14 is 5,760 years. That is every 5,760 years, half of a mass of carbon-14 decays away. What is the K value for carbon-14? This seems really intense, okay? So let's break this down a little bit. Let's write our equation down. Y equals A times E to the negative KT. Y is saying how much is left. Well, it says it's half of it is left, right? Half of it is left. So what is half as a decimal? 0.5. So we're going to say 0.5 of the matter is left. And we started with A. A is always just going to be 1A. So that A value, there's always a whole number 1 in front of it. We don't have to write it. But that A value will always just be A. Because it's the whole value that's starting. You're starting with a whole piece of something. Okay? So 0.5A means you're taking 50% of A, which is what you started with. And A is always just going to be representing the whole amount. Okay, so now we have this times E to the negative K, which is what we're trying to find. How much time has passed? 5,760. That's what's going to go in for the T value. Remember, we are solving this for K. This is a brand new problem that you probably have never done before. So I want to make sure that we're talking about it as we're going. We can go ahead and get rid of, if we're trying to solve for K, what it makes sense to get rid of these A's first. Okay, drop those out. How can I get rid of A? What can I do to get rid of it? Good, divide on both sides. So I'm going to divide this side by A and this side by A. So on both sides, my A cancels out. So I'm left with 0.5 equals E to the negative 5,760K. I just switched the coefficient around to the front. Right, because we're used to seeing the coefficient in front of the variable. Right, that's how we're used to seeing it. So I just switched it around. Does anyone remember from the lesson where we talked about E, how you get rid of E? What cancel? What's the inverse of E? Do you guys remember? What? ln. You guys remember the ln thing? ln, which is natural log, and E cancel each other out. Okay, so if ultimately, I'm trying to get this K to drop down, but it's an exponent right now. And I can't get it to drop down unless I get rid of that E value. So I'm going to take the natural log of both sides. Because whatever I do to one side, I have to do to the other side. So when I take the natural log of the right side, this ln and E cancel each other out.
What is the
Natural log is just another part of the logarithm family.
Cancels the E out.
Yeah, it just cancels the E out only.
So you don't have to actually do anything to the
Correct. You don't have to do anything. So I have on the left side, I have ln of 0.5.
Did that parentheses around there?
It doesn't matter if you have them or not. Equals now my E is gone, and so my exponent can drop down. Remember, we're solving for K in this whole long process. So how do I solve for K here? What do I need to get rid of? I'm not going to add it because it's not being subtracted. Is it as a negative? What did you say? Divide. So I'm going to divide both sides by negative 5,760. Divide by negative 5,760. And we're going to use our calculator. You're going to get a very small decimal. And that is okay. Make sure that you put your negative sign in there. So the natural log, so you're going to make sure you hit the LN button on your calculator. I'm going to take the screen away for just a minute. You guys all see where the LN button is? Over there by the 4. So I have LN of 0.5 divided by negative 5,760. And we're getting 1.2033. Is that what you guys are getting? Okay. This e to the negative 4 means that you're going to take the decimal and move it to the left 4 spaces. So it's a really small number. Okay, so I'm going to get back to the drawing here. If I have 1.2, what was after the 0? 3. And I have e to the negative 4. This is called scientific notation. 1, 2, 3, 4. And I'm going to fill those blanks in with zeros. A 0 here, here, and here. Okay, I'll do that again, just so you can see it again. It says e to the negative 4, so 1, 2, 3, 4. Fill it in with zeros. So this k value is 0.00012. We're just going to stop it at that, at 1, 2. This means whatever radioactive substance we're talking about decreases at a rate of 0.0012. So this is a really slow decaying object. Right? It took 5,000, almost 6,000 years for it to become half of what it was. All right, so we're going to use this part of K down in problem B. Okay, so the reason we found K was so that we could use it in part B. So let's look at part B. It says a paleontologist. Does anybody know what a paleontologist is?
Yep.
If you didn't know, couldn't you keep reading? It says a paleontologist examining the bones of a woolly mammoth. So what do you think they do?
Dinosaurs.
And they examine bones, right? Examine the bones of a woolly mammoth. Estimates that only 3% as much carbon, set up for me please, carbon-14 as they would have contained when the animal was alive. How long ago did the mammoth die? Okay, so if the mammoth is dead, we need to figure out how long ago he died. So this is how scientists say that dinosaurs lived 20,000 years ago or whatever it is, okay? So we're going to use our equation. Let's write our equation down, please. Y equals A times e to the negative kt. That negative sign is always there. It's part of the problem. How much of the animal is left, does it say?
3%.
Only 3% is left, right? So remember, the amount that's left, we write it as a decimal. So 0.03A. Remember the A on the right side always gets written down. Times e to the, now we know what K is based on the problem we just did up top, right? So we're going to use negative 0.00012. There should be 3 zeros. T. And T is what we're trying to find here. All right, what do we need to do first? Look at what we did in problem A. Divide the A's off. All right, so let's divide the A's off both sides. Remember, I'm trying to get T, right? Quentin, what do we need to use to be able to get that T thing to drop down? Not quite. Chelsea, help him out. You cancel with the ln. Remember, Quentin, we need to get that L or that E off of there, and the only way to get the E off of there is to take both sides to the ln. What'd you say? Yep, you have to do both sides. Why do you have to do both sides, Quentin? Perfect. Whatever you do to one side, you have to do to the other side. And ln and E cancel on the right side. So on the left side, we're left with ln of 0.03. Don't mix up your decimals. Negative 0.00012 t. You can't really see that one. Yes, Chelsea? Okay, tell me the next step. By what? Okay, and we're going to take the negative with it. We're going to divide by negative 0.0012 on both sides. So take a minute and do natural log of 0.03 on your calculator. Bless you. And I'm getting 29,221. Is that what you guys are getting? Okay, what does this mean? So ln of 0.03 divided by, you had too many parentheses, that's why. It automatically pops up a parenthesis for you. So 0.03 divided by. What does this mean, this 29,000? Emily Harris, what does this 29,000 mean?
It means the years that they've been deceased.
Okay, because the question said, how long ago did the woolly mammoth die? So we would say, there you go. The woolly mammoth. I mean, how awesome would it have been to live when woolly mammoths did? There's only one L. Does everyone know what a woolly mammoth is?
Yeah.
It's like a really
Yeah, it's on Ice Age, right? The woolly mammoth with the tusks. Kind of a hairy elephant. That's a good way to say it. The woolly mammoth lived approximately, I don't remember that number, 29,000 what?
221.
21 years ago. We don't need to put the decimal value if we put approximately. Any questions on that problem? We're kind of working the same things out. Okay, why don't you try number 5?
You mean number 6?
Yeah, that's what I meant. Thank you. Number 6. Okay, it's done the same way. Number 6a says the half-life of sodium 22 is 2.6 years. Remember that 22 thing with the sodium is just a label. The 22 doesn't mean anything. Okay? Don't plug 22 into your problem. It's 2.6 years. What is the value of K for sodium 22? Okay, so half-life tells me that how much of the substance is remaining? Half of it, right? So what's going to be my A value, Josh?
Your A value would be...
Or what's my Y value, I mean?
2.6 years?
Okay, so it says what is the half-life? So I'm going to use 0.5 in for my Y value because Y is how much is left. Sit up for me, please. To the negative K, and it says 2.6 years. All right, see what you can do. See if you can solve this out based on what we did in problem 5A. Look back at your notes how we did 5A. Anthony. Sit up for me, please. So look back at your notes, look at what we did. Amanda, what do we do at this step up here on the board?
The ln.
Excellent. The ln on both sides. Would you agree, Quentin?
Mm-hmm.
Good. Josh, what do I do from here? Hang on.
You would, wouldn't you divide it by a positive 2.6 on both sides?
We're gonna do, if it's negative, we're gonna take the negative with it.
Oh.
Okay, so we're gonna divide both sides by negative 2.6. Make sure when you use your calculator that you plug in a negative 2.6. So I have natural log whoops 0.5 divided by negative 2.6 0.26659. Is that what you guys have?
Yep.
Okay, so let's use our k value as 0.2666. Let's use 3 6s.
Can we like add 5 or something?
Can you add a 5?
No. I mean,
Just do 0.2666. Okay, what are we going to do on part B? See what you can do on part B. See if you can set it up. Part B, we're going to use this k value in part B. Okay, so see what you can do. Think about how much is left and where that goes. We have 10% left. So if I have 10% left, that's going to go on my y, 0.10a. Keep going, Josh. Finish out. All right, we had 10% left. We need the k value from up above. Quentin, what do I do here? Okay, divide off the a's. Patrick, what do I do at this point right here? LN both sides. Okay, Tracy, what do I do here? Talk to me a little louder.
Sorry,
Dividing, okay.
-2.
Good. 2666 on both sides. Excellent. And now we rely on our calculator. If you forget to put the negative in on your calculator, your answer is going to be negative. And you can't have negative time, right? You can't say I was gone for like -3 years. Unless you are, what's his name? It's the American soldier. What? Who's the guy? Captain America.
Oh.
He's gone. He's gone for negative time, right? Okay. Did you do natural log? You didn't do natural log. Okay, natural log of 0.10 divided by negative 0.266. Brianna?
8.636.
8 point what?
636.
Anybody else getting this answer? 8.636? If you're not, double check that you put it in correctly. You forgot natural log right here.
Don't you round up?
So 8 points. Let's talk about 8 point. Approximately 8.6 would be a little over 8.5 years, right? So you could say the meteorite hit Earth approximately 8.5 years ago. Because if you have this answer on your paper, and then you tell me in your sentence that it's 8.5, I'm going to give you full credit because I see you have the work there. What's wrong? You have log instead of ln. They're going to give you different values.